Hi everyone, today I'm going to be talking about the K nearest neighbors or KNN algorithm, which is one of the most popular, simple but powerful classification and regression algorithms that is being used in machine learning today. And essentially, what it is, it operates on the assumption that similar data points are located near each other and that we can use that nearness to predict a classification or a continuous value. So just to start, what is machine learning? I know that I'm still getting used to all of these terms, so I just included this as a refresher, but machine learning is a branch of artificial intelligence in computer science which focuses on the use of data and algorithms to imitate how humans learn, gradually improving its accuracy. So, machine learning is the process of training algorithms to recognize patterns in data and make predictions or decisions based on that data. And one of those algorithms is the KNN or K nearest neighbor algorithm that I'm going to be talking about today. So first I'm going to talk about what the KNN algorithm is, and then I'll get into how it works and how it's being used today. But the K nearest neighbor algorithm is a simple but powerful machine learning algorithm used for classification and regression tasks, which I will also explain in detail in just a few minutes. But essentially, just like to give an example, when I was researching for this project, a lot of people explained it like asking for movie recommendations from your friends that like the same type of movies that you like, or if you're new to a town and you're looking for a good restaurant or a good gym or something, you ask around, see what your neighbors prefer, and that can kind of give you a good idea of what you might prefer. So how does it work? The KNN algorithm works by finding the K closest data points to a new data point and uses those neighbors to predict the class or value of that new point. Why is this algorithm important? Essentially, its simplicity, effectiveness, and ease of implementation are qualities that make it one of the go-to algorithms for basic machine learning tasks. So now we're going to talk about how this algorithm works. It can be used for classification or regression, but essentially this is like predicting a classification of a new input, like deciding if a new email is spam or if it's not spam, or regression, which is predicting a continuous value, like predicting housing price based on square footage or some similar feature. So the first step to use this algorithm is to define your K, which essentially defines how many neighbors you will be looking at in your prediction of your specific new data point or query point. The most common choice for K is like 3 or 5, but it can definitely vary depending on the data. These are typical ones because odd numbers are used to avoid ties, and numbers too small or too large might make the model too sensitive or not sensitive enough. This is called overfitting or underfitting. And numbers like 3 or 5 tend to strike a balance and perform pretty accurately in this algorithm. The second step is to calculate the distance. So you measure the distance between the new data point and all the points in the data set to find your K, 3, 5, whatever, closest neighbors. So I won't get too detailed, but usually the distance is measured in a metric called Euclidean distance, which is one of the most common ways to measure a straight line distance between 2 points in a 2D or 3D space. And so after calculating the distance between your query point and all of the rest of your data set, you'll be able to sort the data points by distance and pick the K, 3, 5, whatever you chose, closest points. So your 3 closest points that are the most similar to your new point. And then that can be used to make classification or regression predictions. So how does this work in classification tasks? Remember, classification is about predicting a class or category, like genre of movies, spam emails versus not spam emails, types of fruit, things like that. And the deciding factor for the prediction is majority vote. So you choose the class that appears most often among the neighbors. So a good example of how the KNN algorithm is used in classification would be, like I kind of already touched on, sorting spam or not spam emails to the correct inbox. So to start, we have a data set full of a bunch of emails. Each one is labeled spam or not spam, and they all have certain features like frequency of keywords like free or money. We all know that typically tends to not be true. Presence of special characters like dollar signs or exclamation points, length of email, and things like that. After that, we choose our K. So we say, I'm going to look at the 3 closest emails to our new one and predict its category as spam or not, going from there. And then we calculate the distance. So the KNN algorithm calculates the distance, like I said, typically Euclidean distance metric tells us how close each email in the data set is to our new email. That can change depending on the data set, but that is a pretty typical one. And then we sort by distance to reveal which ones are closest or most similar or nearest to the new email that we're trying to classify. And then let's say we said 3 was our K, 2 of those neighbors are labeled as spam, 1 is labeled as not spam. Like I said, majority vote predicts the category, so if 2 are spam and 1's not, then we would predict that the new email is spam. So how does the KNN algorithm work for regression tasks? Remember, regression is used to predict a continuous value. Classification was a category or something like that. So for regression, it's pretty much the same process. I won't go through all the steps, but just to give you an example, you're trying to find a value like housing price from features like square footage or number of bedrooms of the house. You go through the same steps. Select your K, calculate the distance, find your nearest neighbors, but then instead of the majority vote like we did with classification, you take the average of values of the K neighbors to predict a continuous value. So that's essentially how the algorithm works. Now I'm going to talk a little bit about how it's being used in real world scenarios. So one real-world application of KNN algorithm would be recommendation systems. So anything that uses recommendation engines like Netflix, Amazon, Hulu, anything recommending music, movies, all of that based on preferences of similar users would be using this algorithm. Another real-world application of this algorithm would be image recognition. So KNN can classify images based on features like color, shape, texture, and is used in facial recognition, like searching your photo app for pictures of you, and it can also be used for classifying handwritten digits and letters and things like that. So another one that we kind of already talked about would be spam or fraud detection. So like with the email example, it can use previously labeled emails to detect if something seems like spam or not, or for transactions, detecting unusual patterns in transaction data to indicate potential fraud. So another one would be medical diagnostics. So it's definitely being used in healthcare right now to classify patients based on their symptoms or test results, which is very helpful with diagnoses. So if a patient's test results are similar to those of other patients with a certain disease, KNN can suggest a likely diagnosis and treatment. So to begin wrapping up, I'm going to go over a few advantages and limitations of the KNN algorithm. Firstly, one advantage is its simplicity. It's easy to understand and easy to implement. There is no training phase. Unlike a lot of other algorithms, KNN doesn't need to train a model before making predictions. It just stores the data set and uses that to classify new data points. It's also effective mainly for small to medium data sets. It works quite well, especially when data is not high dimensional, which kind of leads me to the limitations of this algorithm. It's not very scalable, and it does not hold up well with high dimensional data, so like data with a lot of features, because the concept of being near to something becomes less meaningful when there are so many factors influencing it. Another thing is that choosing K can impact results. So a really small K can lead to overfitting, which I kind of mentioned earlier. Same thing with a very large K, leading to underfitting. And then it can be computationally expensive for large data sets. So as the data set grows, the algorithm requires more computational power to calculate the distance between the new data point and every other point in the data set. So that's something that can make it difficult to use as well. So just to summarize, the KNN algorithm, or the K nearest neighbor algorithm, is a simple and effective algorithm used for classification and regression tasks. It compares a new data point to its K nearest neighbors in a data set in order to make predictions, and it has many real-world applications. It's widely used in recommendation engines, image recognition, medical diagnostics, spam and fraud detection, just to name a few applications. And it's simple and very effective, especially in situations where the data is clean and the problem is pretty straightforward. And here are the references I used in case you guys want to take a closer look and learn more. Thank you so much for spending time watching my presentation. I hope you enjoyed.